Asthma is a global phenomenon. According to the World Health Organization, asthma affected an estimated 262 million people in 2019. In the United States alone, the Centers for Disease Control estimates there are over 4.6 million children under the age of 18 with asthma. According to the Global Asthma Report, in 2022, asthma is, quote, well controlled, unquote, in nearly two-thirds of adults. That number drops below 45% in children aged 5 to 14. While it is the most common chronic disease among children, inhaled medication can control asthma symptoms and allow people with asthma to lead a normal, active life. Not surprisingly, areas of lower to middle income are most affected. What if there was a low-cost, reliable, and portable alternative? What would that do to combat asthma and other respiratory ailments? How could Microchip Technology ease the suffering of children around the world? Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. Our guest today is Zhang Feng, Principal Applications Engineer at Microchip Technology, working out of the Medical Products Group. He joins us today from our global headquarters in Chandler, Arizona. Welcome, Zhang. Thank you for joining us on Beyond the Microchip.
Thank you, Maya.
In the intro, we briefly talked about asthma and other respiratory ailments affecting children around the world and what the benefit of a reliable, portable solution would do to combat such ailments. You have a bit of a personal story related to this. Tell us about it.
Thank you, Maya, for giving me this opportunity to share my personal experience on this topic. Something that is very special to me and I can truly relate to. My son had asthma problem when he just turned 5 years old. Every time he caught a cold, it would most likely trigger his asthma. You could hear his cough went deeper and deeper into his airway quickly, and eventually wheezing sound coming out from his lung. He often had shortness of breath and persistent cough, especially at night. And sometimes he couldn't even sleep. He couldn't sleep. We all couldn't sleep. Very stressful to the family. At the time when my son had started showing these symptoms, pediatrician usually prescribed a medicine called albuterol sulfate to prevent and treat wheezing and coughing. Albuterol is a quick relief drug to relax muscles in users' airways and encourage airflow to and from users' lungs. It is available in two forms. One is albuterol inhalation solution that comes in plastic vials package, and it is delivered into user's airway by a nebulizer.
And it's a liquid form, right?
Yes.
Yeah.
The other type is called albuterol inhalation aerosol that comes in metal canister and is delivered into user's airway by meter-dosed aerosol inhaler. Since my son was very young at the time, so pediatricians gave us the albuterol solution with a pneumatic jet nebulizer to use at home for delivering albuterol to his airway. And another kind of medicine that my son had used before to control his asthma over the long term was called Fluent, which was delivered into user's airway by meter-dose aerosol inhaler. In the worst case, when my son got severe asthma attack, doctor had to prescribe oral steroids to him to take for a few days. And that made me very nervous because I heard some side effects for long-term steroid therapy. So a lot of discomfort to my son when taking medication. And I've just mentioned two types of drug delivery device, nebulizer and a meter-dose aerosol inhaler. Both devices send medication into your lungs. You may have seen how a meter dose inhaler works before.
We're talking about the thing that's handheld, right? Yeah,
Yes.
that's it.
It's I got one here with me. It's a pocket-sized L-shaped device. First, you insert the drug canister into the inhaler housing, and there's a meter on the housing showing how many doses left available to you. You shake it, get close to your mouth, then you press on top of the drug canister. It delivers short bursts of puff into your mouth.
Yep.
Like that. As you can see, use an inhaler. First, you need to be strong enough to push down the canister. And then you have to time it correctly in order to take the full dose in. Right? Therefore, inhalers may be hard for very young children to use.
Simple and portable, but not necessarily effective.
Yeah, exactly. A nebulizer is often easier for young children to use because all they have to do is breathe normally. Medical nebulizers are drug delivery devices that break up medications into small aerosol droplets and deliver them directly to users' airway through normal breathing. There are several types of nebulizer on the market. Pneumatic jet nebulizer that my son used before is very common. A jet nebulizer comes with an air pump unit and a special designed long tube with mask. It works based on change in air pressure. The liquid medication along with the compressed air pass through a very narrow tube and enter a wide area.
So you've brought one along here.
Yeah.
So we're looking at a gray, about a football-sized device, and it's got some wires coming out of it. It's got a big, long tube, and that's what you're holding right now is the tube?
Yes, this is this exact unit that my son used before. The increase in the volume of compressed air leads to reduction of its pressure and atomizes the liquid into small aerosol droplets, which patient can directly breathe in. So the jet nebulizer is basically an air compressor in a sense. From my user experience, it has several disadvantages. Due to the nature of its working mechanism, the jet nebulizer produces quite a bit of drug residue. If you didn't clean the tube after each use, it would produce even more drug waste in next use. Additionally, the machine has to be plugged into the wall outlet, and it's loud, heavy, and you couldn't walk around with it during treatment.
Yeah, it looks kind of clunky for a 5-year-old to hold.
Yes. Take albuterol as an example. My son had to use the jet nebulizer 3 or 4 times a day, and approximately 30 minutes for each treatment. Sometimes he needed to do it right before, even during sleep. I think many parents may have very similar experience as I do. My kid didn't like it at all. Seeing his suffering asthma really made me feel helpless as a father. So I began to research asthma, nebulizers, and relevant topics. Soon I came across a project that one of our field applications engineer, Bill Hawkins, had worked on before. It's called vibrating mesh nebulizer.
Okay, mesh versus jet.
After I studied the technology, I realized that that's an excellent alternative drug delivery device that my kid would love to use it for his albuterol treatment, rather than using a bulky and loud jet nebulizer. So Bill and I got together and we decided to develop a complete vibrating mesh nebulizer reference design and demo board. You may want to know what vibrating mesh nebulizer is and how it works.
Well, I'm presuming it's not the air compressor solution that generates a lot of waste.
Oh no, it's completely different. It's a significant innovation made in the nebulizer design by utilizing the vibrating mesh technology. A vibrating mesh nebulizer is a portable electronic device. The system is comprised of a liquid reservoir, a piezoelectric mesh disc, and the piezoelectric driver board. So on top of the nebulizer plastic housing,
and this is the mesh nebulizer right here that you've got.
Yeah.
So for those of you listening at home, comparing this to the jet nebulizers, this new contraption here is about the size of a deck of cards versus this very heavy, very clunky piece of material on the side that has all kinds of wires and tubes sticking out of it. This looks like it could fit in your pocket.
Yes, you could definitely put it into your pocket. So on top of the nebulizer housing is a removable liquid reservoir with a piezo mesh disc mounted on one side of it. The piezo mesh disc is a stainless steel plate containing thousands of precision-formed laser-drilled holes and surrounded by a piezoelectric material. The piezoelectric material will vibrate at very high speed when it's driven by an analog signal with specific voltage, frequency, and waveform generated by the driver board. As a result of rapid vibration, the solution is drawn through the holes to produce a fine particle, low velocity aerosol that can be directly inhaled into the lung.
So the vibration creates the aerosol instead of air pressure.
Exactly.
Yeah.
To generate such signals to drive a vibrating mesh disc, we used Microchip's CIP technology in an 8-bit microcontroller with just a few discrete components to build a single MCU-based battery-powered, pocket-sized nebulizer driver board.
CIP is a core independent peripheral?
Yes. Our CIP technology was it's a perfect match for this application. A single 8-bit microcontroller got everything needed to run a vibrating mesh nebulizer. As a result, our vibrating mesh nebulizer demo was innovative, small, reliable, low power, low cost, and high efficiency, providing an attractive alternative solution for aerosol drug delivery.
So I see that the jet nebulizer has that long tube with that mouthpiece at the end. You actually physically have to put the mouthpiece into your mouth?
It comes with mask attachment or mouthpiece.
Okay. But that's physically touching your son's face.
Yeah.
Versus
you have to wear it.
The mesh nebulizer, which doesn't require that physical touch?
Some of them has a mask attachment, so you can. There's no leaking. So everything you can.
And then this is battery powered, right?
It's battery powered.
So that increases the portability.
Yes.
I imagine you can take that places where you're tethered to the wall with the jet nebulizer.
Yeah, you can take this to watch a movie, and your neighbors wouldn't even notice you're taking medication.
You're taking your asthma medication while the movie's going?
Yeah.
That's nice. Yeah. That's extremely convenient. So it uses core-independent peripherals, and you said it uses microcontrollers, and I heard some analog devices in there. What specifically are we talking about? What devices apply to the applications we've been talking about today?
So CIP, as you mentioned, CIP is short for core-independent peripherals. Inside a general microcontroller, the core or the brain of the device is the central process unit. Then there are many peripherals around the core to carry out different functions, tasks of a microcontroller, such as analog digital conversion, signal generation, timing, input-output control, etc. So our microcontroller CIP, or our microcontroller's core independent peripheral and integrate analog features are designed to implement a variety of functions and applications that do not need constant interaction with the central process unit. Using our vibrating mesh nebulizer reference design as a as an example, there are two major stages to drive the piezo mesh disc. They are boost stage and output stage. The boost stage can boost the battery power to a specific high voltage range. The output stage provides the high voltage sine wave driving signal for the piezo mesh disc. Both stages are implemented using the core independent peripherals of a single 8-bit microcontroller with a few discrete components in a closed-loop control fashion. The boost stage uses several CIPs, including two pulse wave modulators, or PWM, an internal operation amplifier, a comparator, an 8-bit digital to analog converter, and a digital to analog, and the configurable logic cell to implement a boost regulator that runs completely independent from the software. The output stage is driven by the numerically controlled oscillator, or NCO. The fine adjustment range of NCO allows the output stage to be tuned to a particular piezo mesh disc attached to the nebulizer. And output current and the voltage are monitored by internal op-amps and ADC. Software configures the peripherals and enables the output, but after that, the boost stage and output stage require no software interaction. Therefore, our solution proved to be high efficient, safe, and reliable. So let's turn my nebulizer on, and you can tell the difference between my nebulizer demo and the jet nebulizer demo.
Yeah, let's start with the old one first.
Okay. Here's the jet nebulizer.
Oh boy.
And
that thing sounds like a machine.
And this is my vibrating mesh nebulizer.
Can't even hear it.
That's the point.
So it's just an on and off situation, right? Are there variable speeds, or does it just go power on, power off?
For a basic design, it's just power on, power off.
So suppose one of our listeners has a use case for this technology. They're hearing your story. They're hearing how you solved this problem with core independent peripherals. Where would they go to learn more? Where could we send them?
They can visit the nebulizer demo landing page at microchip.com/nebulizer to get more information. And we have published an application note AN2265 that explains our nebulizer reference design in detail. And you may contact your local Microchip representative to request a demo hardware for evaluation.
And I think we'll post all of those links in the show notes for anybody that wants to download. And I think you can also go to microchip.com/asthma to find out more about what we talked about today. So you took an existing technology that was heavy, bulky, kind of clunky. It required you to plug it into the wall. You had to have an interface design with the child's head. And then you took that and you shrunk it down. You made it portable. You made it more efficient with less waste. And you can take it with you. So that's a dramatic drop in scale, dramatic increase in efficiency, and a dramatic loss in power. That's a wonderful evolution for how you've taken the existing technology and you've made it better. Do you have any predictions for the future of these types of medical devices? How their technology could enhance the human experience, like what we talked about today? Albuterol is one form of liquid medication, right?
Yes. Bottom line is I would love to see this type of home use drug delivery devices becoming more and more effective, portable, user-friendly, and affordable. Not necessarily just for albuterol, and it will be hopefully applied to many other drugs. Maybe
Not just for asthma, right?
Yeah, not just for asthma.
But it works effectively with any liquid? Could you make aerosol out of any liquid medicine?
I think each medicine requires may have different slight requirements. For example, the size of droplet depending on how far you want the medication travels in your airway. You want to just in the mouth area, airway, or you deep into your lung. The size of droplet, the hole of the vibrating mesh disc determine the size of the droplet.
Mm-hmm.
So the drug manufacturer may have a requirement on a specific drug.
For the size of droplet necessary.
Droplet, yeah.
And I also noticed that you've got a plugged-in USB. So this is available in multiple places. Anywhere that you have USB power, it should be easy to convert it and charge it.
Yeah, it's a rechargeable battery.
Right, but the best part is you can take it wherever you need it.
Yes.
You don't have to be in one place.
Yes. And, back then my son was watching Thomas and Friends, the cartoon and the book.
Uh-huh. Thomas the Tank Engine.
Yeah. I was also thinking someone should make a choo-choo train looking nebulizer based on our reference design. There should be a good market for that.
Yeah. Well, the technology lends itself being as small and easy to access as that.
Yeah. And our nebulizer demo is a single microcontroller design. It's very simple and reliable. It can compete with any ASIC design out there on the market. And using microcontroller gives designer much more flexibilities to implement many more add-on features additional to the basic nebulizing function. So remember, the nebulizer has a separate removable drug reservoir.
Mm-hmm.
So we installed one of our Microchip's crypto authentication chips, AT-SHA-204A, onto the drug reservoir. So now only authorized drug is allowed to be used by the nebulizer. So this tiny secure element will address many security concerns like drug authentication, intellectual property protection, cloud authentication, secret key or data storage, and consumption tracking. And you ask me any predictions, and one more prediction for future use of this type of medical devices is it's not only for delivering medication, at the same time, it may be able to providing anonymous feedback information to the researchers securely.
Analytics. Yeah.
Yeah,
That's something your existing solution certainly doesn't do. It doesn't look like it plugs into any way to capture how it's used.
For example, using the usage information plus environmental information to create a regional map for similar illness, and then run the data through AI models to study and improve the effectiveness of the medicine.
Yeah,
Yes.
So you mentioned something that I didn't catch before, is that you can authenticate the medicine that you put in your solution versus it doesn't matter what you put into the jet nebulizer.
Yes.
There's no way of knowing.
Yes.
Yeah, that's a big deal for security.
Mm-hmm.
So medical security is something that's definitely going to start affecting us much more.
Well, security in general is becoming a hot topic, and medical security, of course, it could impact the people's life.
Mm-hmm.
So we've been seeing many customers implementing security features, either in embedded security in the chip level or in the network, in the data center, in the cloud. So in all respect, security is becoming more and more a requirement. by the manufacturer.
Yeah, I think you were saying the medical Internet of Things.
Yes, that's since pandemic happened, home healthcare or telemedicine is becoming more popular. So being able to monitor the medical device using at home, we have total system solutions to support such application to get the data in and out from a medical end device securely.
Any final thoughts, John?
With our nebulizer demo, we already have several design wins worldwide for drug delivery applications. I really hope that it can help people out there. After all this pandemic happened, suddenly I realized humans are still vulnerable to many diseases. I really hope one day we could find cures for all diseases. This project really resonated with me because to see someone, especially children in this case, who may benefit from something that we created, something that may help improve their lives and their health, it's the most rewarding part about what we do here at Microchip.
This has been wonderful, Zhang. Thank you so much for your time.
My pleasure.
Zhang Feng is Principal Applications Engineer at Microchip Technology, working out of the Medical Products Group. He joins us today from our global headquarters in Chandler, Arizona. Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.